three distinct numbers are randomly selected from this set of first 40 natural numbers, right? The numbers 1, 2, 3 up to 40. If the probability that selected numbers are in an increasing GP, increasing GP means that if first term is positive, the common ratio is greater than 1. So the probability that selected numbers are in increasing GP, this is m by n, where m and n, these two are co-prime numbers, their HCF is 1. Then we have to find the value of m plus n. Now again, this is a problem where we have to consider the different cases, right? Here if we talk about number of elements in sample space, so total 40 elements are there and we are selecting any 3 elements from there. So the total number of ways of selecting 3 elements, this will be 40C3. 40 distinct numbers, we have to select any 3 number. Now next we have to talk about favorable cases. Favorable cases are those cases where those selected numbers are in a GP with common ratio greater than 1, right? Increasing GP because all the numbers are positive numbers. So we'll get an increasing GP when the common ratio is more than 1. So here we have to count, basically the problem is we have to count that in how many different ways we can select 3 numbers so that they will form an increasing GP, right? And then our probability will be number of favorable cases by total number of cases. Total number of cases is 40C3. Now see, for finding number of favorable cases, we have to consider the different possibilities. So basically we have to think about the common ratio R, and then we have to see that how many different GP we can create. Also, because it is an increasing GP, common ratio must be greater than 1, right? So on one side we'll write R, and on another side we'll see how many different GPs are possible. Increasing GP, common ratio more than 1, and because all integers are there in this set, so common ratio must be integer, right? It cannot be fraction because then you will not get terms from this set. So if the common ratio is greater than 1 and it is an integer, so it has to be either 2 or 3 or 4 and so on. Now, suppose if I take common ratio as 2, so let us see how many GP we can create with common ratio 2. One possibility is that first term we can take 1. If common ratio is 2, next term will be 2, and then next one will be 4. So this is 1 GP with common ratio 2. Similarly, if I take first term as 2, the next term will be 2R, and the next one will be 2R square. So this is the next GP, 2, 4, and then 8. You can see that if first term is 3, then next one will be 3 into 2, 6, and then 6 into 2, 12. So in this manner, we can create number of GPs. And the last one is, if I take 40 as the last term, then the second last term will be half of that. So that means 20. And the third last term, I mean the first term of that GP will be 20 by 2, that is 10. So in this, if the common ratio is 2, then these are the 10 GP that we can create, right? If we see the first term only, I mean, how many GP are here? So just notice the first term, 1, 2, 3 up to 10. So 10 GP we can create if the common ratio is 2. Now think of the next possibility. If the common ratio is 3, then first term 1, next one will be 1 into 3, and next one will be 1 into 3 square. So 139. This is a GP with first term 1, common ratio 3. Another possibility is that we can have 2, 2 into 3, 6, 6 into 3, 18. And you can see that we'll get only a few GP because when here every number we are multiplying with 3, and once you cross this last number 40, then you cannot have terms from here, right? So that means next possibility will be if I take first term as 3, 3 into 3, 9, and then 9 into 3, 27. If I take first term as 4, 4 into 3, 12, 12 into 3, 36. And if I take first term as 5, then next term will be 15, and then 15 into 3, 45. 45 is not there in this set, right? The moment you cross 40, I mean, we have to stop counting. So these are the 4 GP, common ratio 3. Similarly, if I take common ratio 4, then we'll get 1, 4, 16. This is one possibility. If the first term is 2, then we can have 2, 4 into 2, 8, 8 into 4, 32. And if I take 3, then we'll get 3, 24. sorry, 3 and then 12 and then 48. So again bigger than this number. So there are only two GP with common ratio of 4. These are the two GP. First term 1, 4, 60, first term 1 and then 4 and 16 or 2, 8, 32. Similarly, if I take first term as common ratio as 5, then first term we can have 1, 5 and then 25, and the next one will be 2, 10 and 50. Now again 50 is not there in that set. So there is only one GP with common ratio of 5. If I take common ratio 6, then we can have 1, 6, 36. Again, there is only one GP with common ratio 6. And with 7, you can easily see that even if I take the first term as 1, the GP will be 1, 7, and then 49. Again, 49 is bigger than this number. So these are all the different increasing GP. Right? First, we have to take the common ratio, and then we have to count how many GP we can create, considering the fact that we have to take numbers, we have to select the numbers from this set, from the first 40 natural numbers. So now these are all the favorable cases, right? We got 10 GP here, 10 plus 4, 14, plus 2, 16, plus another 2, 18. So if uh, and it is given that probability that will get increasing GP, this is m by n. So that means m by n, this must be number of favorable cases by total number of cases. Number of favorable cases 18, and then total number of cases, this we are getting 40C3. Total 40 numbers are there. Select any three number and that will give us one case. So number of elements in sample space 40C3, favorable cases 18. And after simplification, you can do the calculation on your own. You will get 9 divided by 4940. So these are this will be the value of m by n, and there is no common factor between these two, right? 4940 is not multiple of 3. So these two numbers are co-prime numbers, or their GCD or greatest common divisor is 1. So now we need to find m plus n. So clearly you can see that if I add these two numbers, we'll get 4940 plus another 9. So that is 4949. So this should be the correct answer for this problem, right? So this was not a difficult problem. Just count the different cases. Total number of cases 40C3. And for favorable cases, we have to consider the different common ratios. And because we have increasing GP, so common ratio should be greater than 1. And only integers are involved here, so common ratio cannot be fraction. So we have to start with common ratio 2, 3, 4 up to 6. And then we got 18 favorable cases, total 40C3. After simplification, the answer will be 4949.